In this video, you will be learning about widening and narrowing. This concept is related to conversion of data type of given data item. So let us understand this through example. See, I have some variables kept here. This is a variable of type byte. Here you can see on the left hand side. And its value is a 10. Don't look at the value. What is the size of the value? Like 10 is a very small number. Don't look at the value. I have given 10 in all the variables, right? So don't look at the number. But see the data type. It is byte. Byte means we know very well that it takes just one byte, isn't it? Then I have one more variable, that is short, S. So this is S. And we know short takes 2 bytes. 2 bytes. Now let us come to the point. I want to assign S assigned with B, means in a short variable I want to store the value of byte. So will this 1 byte of data easily accommodate inside 2 bytes or not? Again, I am telling you, don't look at the number. Whatever the contents are there inside this 1 byte, can it accommodate in this 2 byte? It is just like, imagine there is one box and here we have 2 boxes. I have some content inside one box. So can you put this content inside this 2 boxes together? 2 boxes together. So the capacity is of 2 boxes. It's bigger capacity, right? So we can see it as a single variable. So 2 boxes together. Yes, it can easily accommodate. So that's it. So conversion of byte type data to short type is widening process. This is called as widening. So here byte type of data will be converted into short type and it can easily accommodate it. So this process is called as widening. Now similarly, can byte type accommodate inside integer type? Integer type is of 4 boxes, 4 bytes are there. So whatever is there in 1 byte can easily accommodate in 4 bytes. Yes, it is compatible. So byte can accommodate in this one. So what about short? Short, can it accommodate inside integer? If I say integer I assign short, means whatever is there in S, keep it in I. Yes, it is possible. This can be stored in this one easily. Now I will define widening. What does it mean by widening? Storing the data of a smaller size data type into a larger size data type can be done automatically, implicitly. This can happen implicitly, automatically by the compiler, and this process is called as widening. When you assign S assign B or I assign S, then compiler will not give any warning, will not give any error message. It will comfortably convert that store into another variable. The reason is the source data type is of smaller size than the destination data type. Source is smaller, destination is larger. So this process is called as widening and it is done internally. So it is called as implicitly, automatically. So one more point in widening, the data type should be compatible. Source and destination must be compatible. So byte is compatible with short as well as integer, right? They are compatible. And byte is smaller than integer. Either the source should be smaller or equal also. For equal also it works, all right? Or it is smaller than the destination. And they must be compatible. So 2 points. First point is size, okay? Other point is compatibility. So size and compatibility, these are the 2 important things. If this is there, then widening is done, which happens implicitly, If these are not satisfied, these 2 points are not satisfied, then we have to do it by ourselves. That is explicitly we have to do, and that is called as narrowing. So when this is not satisfied, means source data is larger than destination data and it is not compatible. So already I have shown you with examples of sizes. Now let us come to compatibility. See, here I have float type of variable f and this is I, integer. So can I store integer inside f? means I is assigned to F. I want to store these 4 bytes into this 4 bytes. So the size is same. So first condition is true. But what about compatibility? Integer is compatible with float because integer value is without decimal. So it can be stored inside float. But the other way, can I store float inside integer? Can I write like this? I assign float means I want to store float value inside I. No, it is not possible because float may be having decimal point value also, and this integer cannot store decimal point value. So this is not allowed. This is not allowed. Float cannot store into integer, but an integer can store into float. This is allowed. So I will take some examples and give you the demonstration to show you how widening works and when we have to do narrowing. And one last important term is that widening is also called as upcasting. Upcasting, I am writing here on the top, and narrowing is also called as downcasting. Let us look at this through an example. Here I will declare variables of various data types, then we will continue discussion. I have different type of variables here. Byte type of variable, I have taken a letter B. Then for short, I have taken S. First letter I have taken, right? So with this, you can identify the variables, which type it is. Integer is I, long is L, float is F, and double is D. Character is C. And for Boolean, already B I have taken in the beginning, so I have taken BL for Boolean. So all the data types I have taken. Now let us check. I will try to assign byte assign short. Not allowed. It is an error. Because destination B is smaller. If you read the error, incompatible types, possible lossy conversion from short to byte. This is not allowed. Widening cannot be done on this one. If you want to force it, then you have to do narrowing. Let us check for other variables for widening. See, can I say short assign byte? Yes. Can I say integer assign byte? Yes. Long assign byte? Yes. No error means it will comfortably convert the right hand side to left hand side data type, right? From byte to short, byte to int, and byte to long. Float assign byte? Yes. Long assign byte? Yes. Character assign byte? No. Character, we can assign only character, or we can assign an integer value. But we cannot assign any other thing. Byte cannot be assigned. Byte cannot be assigned. Though you see, character takes 2 bytes and byte takes only 1 byte, but they are not compatible. Size is bigger, but they are not compatible. So this is not allowed. So obviously, Boolean assign byte to Boolean, you cannot assign any other type. Yes, you cannot assign it all. So byte can be assigned to all the data types. Okay, let us check with the short. Byte assign short, not allowed. Integer assign short, yes, allowed. Widening is happening here. Long assign short, yes, allowed. Float assign short, yes. Double assign short, yes. All are widening, but here it is not allowed. So if you want to force it, then you have to do narrowing. So now I will show you narrowing. Assign, see, B assign byte. There is a possibility of loss of data because short is 2 byte and you are trying to accommodate in 1 byte. So you may not get the same data, right? So, but by writing this byte conversion here, typecasting it here, we are saying that we are ready to bear that loss. So you should do it if you know that the value inside short is small enough to accommodate in byte, then only you should do this. Like short is having 10, so 10 can easily accommodate in byte. Now you can look at the value, right? If you have a bigger value in this short which cannot accommodate in byte, then you will definitely lose the data. I will show you that one. Here I will print it, system.out.println. I will print the value of byte. See, I should get the value 10 in byte. Yes. So already byte was having 10, so I will change it. So you should not get confused that same 10 it is showing. No, I have changed it 10. Now inside short, I will take a bigger value which cannot accommodate in byte. So I will take 200. See, minus 56. When I have stored it in byte, I am not getting 200 because the maximum positive value that I can store in 1 byte is 127. So 200 is bigger than byte size. So we lost the data, we got something else. So when you are narrowing by typecasting it, so you may lose the data. So be careful that you have the size of the data that can easily accommodate. So now if I make 120, then it should easily accommodate. Yes, byte is getting 120. So this is about narrowing. So when widening is not possible and when you want the conversion, then you have to go for narrowing and downcasting, and you have to typecast it. So let us check other data types. Okay. See here, integer assign float, not allowed. Float assign integer, allowed. Integer assign float, because float is of decimal value, it cannot store in I, it is not compatible. But I assign F, it is allowed. What about double assign float? Yes, it is allowed. Float assign double, it is not allowed because double is bigger. So smaller size on the right hand side and bigger size on the left hand side allowed. If you want to force it, then you can typecast it, right? So here also, if you want to force, then you can typecast. So if float value is having 10.5 F, I will show it separately. You can clearly see the line. These I will remove. Now you can see here, float value I am assigning into an integer. Float value is 10.5. 0.5 cannot be stored in I. So definitely we will lose that value. Okay, I will print I and show you. See, we got only 10. That 0.5 is lost. That's it. When you downcast by using typecasting and you do narrowing, then you will lose the data. There is a chances of losing the data. So that's it. I have shown you by taking examples. Now let us look it as a chart showing who is compatible with whom. Source and destination. Source is on the right hand side, remember. Okay. Destination is on the left hand side. So the right hand side value, we want to store it in left hand side. So source and the destination who are compatible, I will show it in the form of a chart. Here I have all the data types: byte, short, int, long, float, double, char and boolean. On the top also I have. So this is for the right hand side, source. And the top one is for the left hand side, that is destination. Source byte can be stored inside byte, inside short, inside long, that is int and long and float and double, and not in char, not in boolean. So byte is compatible with all of them. So when I am showing compatibility, tick mark, right mark is nothing but widening will happen. Okay. Otherwise you have to do typecasting, but it is not possible for boolean also. Even typecasting is also not possible for boolean. Now what about short? Short is not compatible with byte, but with short itself and int and long, float, double, not with char, and here not at all possible. So boolean is only compatible with boolean. None of them, right? None of them. It is not compatible with anybody. So let us remove it. Though it is there as a data type, so I have shown it in the table. So it is not compatible with anybody. Okay. Now integer. It's not compatible with int, byte or short, but about int, yes, and long, yes, float, yes, this also, and for character also, yes. And what about long? No, with long and float and double, and here again no for the character. Then for float, it is not compatible with anybody, right? None of them, but itself and double. And double is not compatible with anybody, okay, but itself, double, that's all. So topmost one is double. And character is not compatible with byte, short, but yes with int, and long is greater than that, so float also, double also, and character itself also. That's all. So I have filled the table, so I have discussed everything. Now there is one more method of showing. Usually if you search in books or if you find on internet, you will find a different chart for this one. So I will show that also. Byte is compatible with short, and short is compatible with int, and character is also compatible with int. So here the sizes are increasing, data size is increasing, right? and then it is compatible with long. So when int is compatible with long means all are compatible with long. That's how the path shows that. Okay. And the long and int both are compatible with float, and that float is compatible with double. So you can remember like this. This is easy. So that's it. That's all about widening and narrowing. In narrowing, you have to do typecasting for downcasting, right? So explore this topic. This topic is only for exploration. So you try to do it by yourself. Check all those data types, take them and just check it once by yourself. That's all in this video.